All right, hello everyone. Today I'm talking about section 8.4, simplifying rational expressions and multiplying and dividing rational expressions. Ladies and gentlemen, the number one thing that we want to talk about today is the idea of factoring and canceling. Again, you got to have strong fraction skills in this section. Today's fraction skills is really reducing fractions or multiplying and dividing fractions and being able to cross cancel. All right? The first thing we want to take a look at is something we've been talking about for a while now, and that's the idea of when you have a variable such as x in the denominator, don't forget that you have to worry about restrictions. Right? You can't choose values for your variable that make your denominator 0. Remember, we talked about this also before. You always want to state your restrictions before you simplify. All right, so let's go through this. Take a look at a couple of examples here. The first one, I've got a single fraction, 2x squared minus x minus 6 over x squared minus 4. The first thing I say to myself is, does this fraction simplify? Can I cancel any common factors? All right, so I want to factor this top. Well, this top factors into, let's see here, factors of negative 12 that add up to or subtract to negative 1 or negative 4 and 3. So when I factor this, I'm going to get x minus 2 and 2x plus 3. Factor this at your leisure and make sure that I did this correctly. And that'll be divided by, on the bottom, x plus 2 and x minus 2, because I've got a little bit of sum and difference going on there to get that difference of two squares. Alrighty then. Alright, so do we see any common factors here? Well, sure we do. We get x minus 2's to cancel. So my reduced fraction, or rational expression, is just simply 2x plus 3 over x plus 2. So that is the reduced fraction. Now let's take a look at the domain. The domain is any value of x that would make the denominator 0, including values that might have already gotten canceled out. Well, from the first parentheses in the denominator, would you agree negative 2 would make that bottom 0? And in the second parentheses, x equals 2 would make the second parentheses 0. All right? So those are the two numbers that I've got to avoid in my domain. So my domain is negative infinity to negative 2, yin yin negative 2 to 2, yin yin 2 to infinity. All right? Just kind of putting a couple of ideas together. If this had been in a function like f of x equals, which we've been graphing, if you think about it, we know that x equals 2 would have produced a hole somewhere on your graph, and x equals negative 2 would have produced a vertical asymptote. And as we said in the functions we were graphing them, we know that those are excluded from our domain. Okay, now let's take a look at the next problem. In B, I've got 6x cubed times y to the 4th over 4x to the negative 2 y to the 7th. Now this problem is actually a blast from the past from chapter 6. In this problem, the first thing I say to myself is I don't like negative exponents. So in this problem, I'm going to move this x to the negative 2 power up to the top and create 6x cubed y to the 4th x squared over 4y to the 7th. And now I just simplify my common factors here. 6 and 4, those are plain numbers, so that simplifies to just 3 over 2. The x's, since they're both on top, we add their exponents because they're multiplied. That becomes x to the 5th. And the y's, since they're over each other, they're dividing. We subtract our exponent. I have 7 y's on the bottom, 4 y's on the top, so it must mean I have an extra 3 y's left on the bottom when I cancel. All right? So this is my answer to this simplified fraction. Now on this one, when you look at the domain, we had an x in the denominator. We have a y in the denominator. So in this, we say that our restrictions are, in this, our domain would be all numbers but 0. So negative infinity to 0, union 0 to infinity. All right, in C. C is a curious little problem where I've only got a single factor on the top and a single factor on the bottom, and they look similar, but one of them is x minus 5, and the other one is 5 minus x. Right? They're not identical, so it doesn't look like I can factor. But if you think about it, there are two things I can always factor out of two numbers. And then one of the numbers is 1, which is boring, and the other number is a negative 1. If I take a negative 1 out of this numerator, if I factor out a negative 1, wouldn't that make this x become a negative x? And if I take a negative 1 out of a negative 5, wouldn't that become a positive 5 here? So I get negative 1 parentheses negative x plus 5, and that's over 5 minus x. Right? Now if you think about this numerator, isn't negative x plus 5 the same thing as 5 minus x in reality? So now by taking out that negative 1, I have identical factors that cancel, and so my final answer to that is negative 1. My domain for this guy would be negative infinity to 5 union 5 to infinity. Because remember, we always find our domain before we simplify, so I had to look at that original denominator. All right, let's take a look at some multiplying and dividing of rational expressions. I take a look at this problem here. I've got two fractions multiplied, 2x minus 6 over x cubed plus 4x squared plus 3x times x squared plus 3x over 2x squared minus 7x plus 3. All right, in this problem, what I'm going to do is I'm going to look at each individual numerator and denominator, factor them, and then see if we have any common factors on top and bottom that we can cancel. In the first top, I can take out a 2 from both terms. So I get 2 quantity x minus 3. In the first denominator, I can take out an x, giving me x squared plus 4x plus 3. But then the expression on the inside, I can factor that even further into x plus 3 and x plus 1. In the second numerator, I can factor out an x, so I get x quantity x plus 3. And in the second denominator, I can see here, what multiplies to give me 6? It adds a negative 7, there's negative 6 and 1, so that would factor into x minus 3 and 2x minus 1. All right, now that I've got my denominators factored, let's see if anything cancels. I'm actually going to take out this middle step so that he doesn't confuse me. Let's see, I've got an x minus 3 in this numerator, and I got an x minus 3 in this denominator. Those cancel. I got an x plus 3 and an x plus 3. Those cancel. And I got an x and an x, which cancel as well. So what am I left with? Well, in the numerator, I'm just left with a single 2. And in the denominator, I've still got an x plus 1 in the first parentheses and a 2x minus 1 in the second parentheses. And that's my simplified fractions. Now, for the domain, again, guys, we have to find our domain before we canceled. So in the first denominator, I had a plain x, so x would be equal to 0. In my second one, I get x equals negative 3. And in my last parentheses, I get x equals negative 1. On the second denominator, I have x equals 3 and x equals 1/2. So putting these in order from smallest to largest, my domain will be negative infinity to negative 3, union negative 3 to negative 1, union negative 1 to 0, union 0 to 1/2, and then 1/2 to 3, and then 3 to infinity. And that is some massive domain that we had to write out there. All right. And that's how we do multiplication. Guys, B, this example B, well, again, that's a problem out of chapter 6. So you guys consider that on your own, and we can take a look at that in class tomorrow. All right, let's take a look at one more example. In this last example, I'm dividing two fractions. Folks, don't forget that we never divide by fractions. So the first thing that I want to do is change this to a multiplication problem. This becomes 2x squared plus 5x plus 2 2x squared plus 5x plus 2 divided by 4x squared minus 1 times, and don't we always multiply by the reciprocal of the second fraction? So I get 2x squared plus x minus 1 over x squared plus x minus 2. All right, so now I'm going to go through and I'm going to factor each top. This first top would factor into 2x plus 1 and x plus 2. The first bottom factors into 2x plus 1, 2x minus 1. The second top factors into x plus 1, 2x minus 1. And the second bottom factors into x plus 2, and x minus 1. Counting out common factors, I see that I've got a 2x plus 1 and a 2x plus 1 that are gone, a 2x minus 1 and a 2x minus 1 that are gone, and an x plus 2 and an x plus 2 that are gone. So lo and behold, my final answer to this is just x plus 1 over x minus 1. Now, I got to find the domain. On this one, you got to be careful. Folks, take a look at this sentence above this problem. Warning, when you're working with a division problem, you must include the restrictions of the denominators before you flip that fraction as well. So you're going to have to do both restrictions. The unflipped fraction here, and then the flipped fraction here, all right? So, my domain, well, again, if you think about it, this was the original numerator, which is now denominator, and this was the original denominator. So these two will both be included in my domain restrictions. And again, this original denominator from the first fraction is also going to be there. I've got x equals negative a half, x equals a half, x equals negative 2, x equals 1, x equals negative 1, and x equals positive a half. So now looking at my domain restrictions, putting all that together in order from smallest to largest, I would go from negative infinity to my smallest number is negative 2, union. After that, my next smallest number is negative 1, so negative 2 to negative 1, union, negative 1 to the next smallest number is negative a half, union. After negative a half comes positive a half, and then lastly, from a half to just positive 1, and then from 1 to infinity. And that's your domain. And that's how we multiply and divide rational expressions. I'll talk to you guys in class.